Today we're going to be talking with you guys about our first concept, and that is going to be constant speed. Some key goals that we're going to focus on in this video is trying to get introduced to key terms that we're going to use to describe the motion of an object. So what exactly is motion? Motion is going to be defined as when the position of an object changes with time, then we say that that object is in motion. And you can see on the screen here, there's quite a few different types of motion that we're going to learn about in physics. But the goal of this video is to get introduced to this topic right here, and that is linear motion. So we measure an object's change in position relative to a reference point. So when we want to know how far an object has traveled, we need to know its starting position. And we're going to refer to that starting position as its reference point. A useful way to think about this is to imagine something moving along a number line. And so we can set the starting point of an object's motion, or its reference point, at a particular position on the number line. So if you look at the screen here, you can see that the reference point is set to 8, and then the final position is 12. So we know, based off the reference point, that the girl here has moved a total distance of 4 units. And we can define distance. This is going to be how far an object has moved relative to the reference point. Typically, we measure distance in meters, but there are a lot of other different types of units, such as kilometers, centimeters, feet, miles, and inches. So if each mark represents 10 centimeters, what is the distance between the girl and the ball? So pay attention to the black arrows. And once again, each little tick mark on that scale represents 10 centimeters. And if you measured correctly, you should have came out to a number of 80 centimeters. But remember, motion is when the position of an object changes with time. So I want you to imagine that the girl from the previous slide, she kicked a ball 2 different ways. And we have our first way up here at the top, and then the second way on the bottom here. Okay? Now, I want you to also imagine that each image of the ball here represents its position along a number line for a particular second. So for example, this would be its position at 1 second, its position at 2 seconds, 3 seconds, so on and so forth. So keeping that in mind, what exactly is different about the motions of the 2 different ways that the girl kicked the ball? And the answer, of course, is that one of them is moving faster than the other. So if we think about this in terms of this ball's position or the distance it's traveled over a given amount of time, our first example on the top here, we know that the ball takes more time to travel the 80 centimeters of distance. Because remember, this is its position at 0 seconds, 1, 2, 3, 4, 5, 6, 7, and then all the way to 8 seconds. In our second example, this is showing the ball moving quite a bit faster. So its position at 0, 1 second, 2 seconds, 3 seconds, and 4 seconds, right? So our example along the top, it takes 8 seconds to travel a distance of 80 centimeters. And along the bottom, it only takes 4 seconds to travel 80 centimeters. And so that's something I think that we probably already understand, is that an object that takes less time to travel a particular distance, it's moving at a faster speed. Which brings us to the topic of speed. We can define speed as the distance an object travels per unit time. We're going to use seconds to measure time. Of course, there are other ways that we could measure that, but for us, we're going to focus on seconds. And speed is going to be measured in meters per second. And you can see here, here's how we would represent that. This is meters per second. And of course, our speed equation is distance divided by time. So if we want to take one of our examples from the previous slide, so our distance for each example of the girl kicking the ball was 80 centimeters. And we'll take one of the examples where it took 8 seconds. So that would look like this, right? So one example was 80 centimeters, and it took the ball 8 seconds. And that would have given us a speed of about 10 meters per second.